Hi guys, welcome to my next video on linear algebra. This video, guys, is going to consist of matrix multiplication and properties of different properties of matrix multiplication and addition. Okay, so let's start the video. Okay, so let A be a set of 2 by 2 matrices with real number entries. Okay. Let M equal 1, 1, 0, 1, and let B be the set of all 2 by 2 matrices such that M times X is equal to X times M. Okay? And let's just, in general, guys, this property does not hold in general. So in general, matrix multiplication is not commutative. So A times B in general is not equal to B times A. Okay, in general. So, but this is a set where any matrix that's in this set is commutative with the matrix M. Okay, so let's prove that the first statement is true. Okay, and the first statement is what? Prove that if P and Q are enclosed in B, then P plus Q is enclosed in B. Okay, so let's make a little space and start solving this problem. Okay, so if P and Q are enclosed in B, then P times M is equal to M times P because it's enclosed in B. And if Q is enclosed in B, same thing. Q times M is equal to M times Q. Okay, so this is our hypothesis. We're saying that it's true. So now let's try to prove this. So if P plus Q, let's start with P plus Q, and let's multiply it by M. Okay, now matrices are can be distributed from the right and from the left. Okay, so this is called the right distributive property for matrices. So P times M plus Q times M. So this is equal by the right distributive property. Okay, so now by hypothesis we can alternate this, right? Okay, so I'm doing this by hypothesis. We're saying that PM is equal to MP and QM is equal to MQ. Okay, and then we could use this M times P plus Q. This is the left distributive property. Okay, so there we proved it. If P and Q are enclosed in B, then P plus Q is also enclosed in B because P plus Q times M is equal to M times P plus Q. Okay? Now let's move on to the next problem. Okay, so prove that if P and Q are enclosed in B, then P times Q is enclosed in B. Okay, where multiplication denotes the usual product of two matrices. Okay, so P and Q are enclosed in B. Fine. So as above, this means that now we want to see if PQ is enclosed in B. P times Q times M. We want to show that this is equal to that. Okay, so then by associativity rule, we could rewrite this to P times Q times M. Associativity of multiplication property. Okay, then we could rewrite this to P times M times Q by hypotheses. Then by associativity again, we could rewrite this to P times M times Q. Associativity of multiplication. Then by hypotheses again, we could write P times M to M times P times Q. Okay, this is by hypotheses again. And then by associativity, we could rewrite this to okay. So there we have it, guys. We proved that if P times Q, this is all equal signs. So we proved that if P times Q times M is equal to M times P times Q, if P times M is equal to M times P and Q times M is equal to M times Q. Okay? So that's it, guys. This is a little couple of problems, little proofs, little linear proofs using the property of matrix multiplication and addition. Okay, so thank you for listening, and if you have any questions on this, please don't hesitate to put it in the comment section below, and look out for the next video. Thank you.